Hello and welcome everyone to this presentation entitled Structural Thermal Model within the MCVT model by Sachin Tripathi of University of Connecticut. The overview diagram of modular coupled virtual test bed is shown in this slide, which consists of highly interactive subsystems, and structural subsystem is one of them. This slide shows the interaction of structural subsystem with other models. And furthermore, this model can be divided into three sub-models, and one of them is structural thermal model, about which I'll be talking today. The main function of structural thermal model is to determine the external surface temperature and temperature variation through wall of the dome habitat structure, and also incorporates the structural protective layer. The diagram provided in this slide is the interaction diagram of structural thermal model with other models. The inputs come from solar radiation model and habitat interior environment model. Similarly, the damageability and reparability information and the material properties are provided by structural protective layer and structural mechanical model. Similarly, the results are outputted to habitat interior environment model, structural mechanical model, and thermal management model. Going into the methodology or physics of the model, the dome structure is divided into several differential elements as shown in figure number 1. Figure number 2 provides the solar ray vector and normal unit vector at any such differential element of a dome structure. The equation provided in this slide is the governing three-dimensional thermodynamical heat equation in polar coordinate system, the discretized version of which was used in individual differential element which was aforementioned. The right hand side provides the energy source and sinks respectively and are illustrated in the figure here. So the heat sources are lunar surface albedo and direct solar radiation. Similarly, heat sinks are habitat surface albedo and non-blackbody radiation. Damageability and reparability features. Whenever there is a damage, the damage element is subjected to external boundary condition. This might lead to the significant change in the surface temperature and the temperature through thickness, depending upon the location and severity of the damage. The diagram here demonstrates the introduction of the damage in the STM. So, during the undamaged scenario, the solar flux hits the outer surface elements directly. Whenever there is a damage as shown here, the solar flux is subjected to the damaged portion of the element. In this example, the impact is considered to occur at the element near to the base, facing the east, such that the sun rays hits that part directly during the sunrise time, which raises the surface temperature as shown in the first plot. Similarly, in the second plot, we can see that the temperature of the inner wall is constant up to 30 seconds, and then it increases due to the damage until the 45 second. After that, due to the repair, the temperature tries to retreat to the original condition. Thank you very much.